Okay. So what we would do is we're solving this linear equation. Now guys, this is why it's linear. Notice all the variable x's are degree 1, right? Okay, so all the variable x's are degree 1. What the heck is going on with my board? There we go. Do you see how they're all degree 1, everybody? That's what makes this a linear degree 1, a linear equation. So what we're going to do is we're going to distribute that 10 through, so we have 10x plus 30, right? Now here's what a lot of people mess up on is they will forget to distribute this negative through to both terms here. So we distribute our negative through, so we're going to have positive 9x plus 4. Does everybody understand? And then over here, let's just combine like terms. So negative 5 plus 3 is negative 2. Over here, let's combine like terms. So we have 19x, right, plus 34. Combining like terms equals x minus 2, right? Now we're going to combine our x's together, but we can't just put them together. We've got to use algebra to get from one side of the equation to the other. So we're subtracting x from both sides. 18x plus 34 is equal to negative 2. Then getting x alone, subtract 34, subtract 34. So we have 18x is equal to negative 36, yeah? Divide both sides by 18. So we get x is equal to negative 2. How many got it right? Raise your hand. Awesome. How many of you were close, made a little error, but now you see it? Okay, just as good. Okay, that's why we're doing this. All right. So today we're going to be reviewing how to factor. This is something that's huge in the core in secondary math 2. You should all know how to do this. However, the way I teach it might be different than your teacher. Now, I'm going to be honest. My kids, when they leave my class, are factoring geniuses because the way I teach it allows you to be able to factor anything I give you. No matter what, this is the only method you need. If you can do this method I'm going to teach you, you can factor anything. You don't have to learn tricks. You don't have to learn anything. So with that being said, like my kids are factoring geniuses. So if you've learned a different way and you can factor that way, that's fine. I'll let you do it. However, if you say to me, oh, I can factor this other way, is that okay? But then I don't know how to factor this one. I'm going to say, factor my way. Factor anything my way. So you all should just learn it my way because we're literally going to factor about 80% of the lessons in secondary math 3. You will not be able to get by with just being okay at factoring. You're going to have to be excellent at it. And that's why we're going to practice, take a full day and make sure we're good with it before we get to the lessons where you need it. Does that sound fair? Okay, awesome. So I'm going to treat it like you have never learned factoring before because it's been a long summer, and now your brains are more developed. When you see it a second time, hopefully it's going to make more sense. I'm going to just stress it again. All right, so first of all, let's talk about, we're gonna learn how to do the greatest common factor first. So greatest common factor, when you factor out the greatest common factor, what we're essentially doing is we're pulling out the greatest thing in common in each term. Now you're like, if you're thinking, what's a term? Terms are separated by plus and minus signs. So let me show you. Look at this. 2x plus 4. There's 2 terms. Do you understand what a term is, everybody? Yeah. Okay. There is 3 terms here. There's 1, 2, 3, 4 terms here. Do you all understand what a term is? Okay. So what we're going to do is we're going to look at each term and factor out the greatest thing in common. Pretty simple, and we'll be able to fly through this. So we're going to start out pretty basic here. Let's pull out the greatest thing in common in 2x plus 4. What does this term and this term have in common? A 2. Now watch, everybody. We pulled out a 2 because there's a 2 in common. Now we're going to go back and see what's left inside the parentheses. We weren't able to pull everything out of term 1. So we're going to pull out a 2, which what we did essentially, guys, is we divided that out. So I'm going to go back through and say, okay, what's left in the first term? Let's divide by that, what we pulled out. So 2x divided by 2. Isn't that an x left? And then we pulled the 2 out of 4, which means we divided out of 2, and that's positive 2, right? X plus 2. Now, do you see how that's our answer. If we redistributed, we'd end up back here, right? So we know we've done it correctly. So starting out basic, what's in common in x squared and x? They each have an x, so now we weren't able to pull out everything. So we divided by x. X squared divided by x is x. Now, don't say x over x just goes away. No, that's not how that works. What's anything divided by itself? 1. Now there's our factored form, and you can check your answer. If I distributed that back through, do I end up back here? Yes, I do, so I've done this correctly. Do we all understand? Let's do some more difficult ones here. So 1A on the There was a sheet on your desk. Grab one of those if you didn't already. The note space so that you don't have to write down the examples and you can take that home as a resource. So like I said, honors people, this is really easy for you. We're gonna get into the new stuff around mid next week. Anyways, here we go. So what's in common here? A 4, there's a 4 in each, right? What else? X and what else? Y. Okay, awesome. So we pulled out a 4xy to see what's left in your parentheses. Go back and divide each term by what you pulled out. So then 8 divided by 4 is 2, x over x is 1, y over y is 1. 2 is left. And then we go on to this term, the 4's divide out, the x's divide out, y squared over y is? Y, it was positive, so plus y. We're all comfortable with that. We could check our answer. I'm not gonna, but we could. Awesome, you guys are good. Okay, here we go. Looking at this, 8x minus x squared. This is actually quadratic, meaning degree 2, so we can factor it by what we're going to talk about in just a second, but there's a much easier way. There's 2 terms, what's in common? X. So we're going to go back and then see what's left in each side of the in each term. In our parentheses, so we have a 8 left, right? Minus x, yeah. Right? Okay, pretty basic here. Feeling good. All right, looking at this one, when factoring out the GCF, if there's a negative in the leading term, now leading means the term in front. We do this for a reason. It's going to help you later on. Like I said, you have to be factoring junkies to be able to be in this class. So right here, do you see how there's a leading coefficient of a negative? Anytime you see that, you're going to factor out a negative with your greatest common factor. And we do that because it's going to help us later on in life. So let's see what's in common. Ignore the negative for a minute. What's in common in each term with numbers? We're pulling out a 4, definitely, right? Definitely a y. That's it. Now, because there's a negative in front, we're actually going to pull out negative 4y. So now make sure when you go back to see what's left in your parentheses, divide each term by negative 4y. You've got to be really careful here. Negative 4 over negative 4 is 1. X, we still have an x, right? And then y's divide out to be 1. Comfortable? And that was positive. Okay. So now look, 8 divided by negative 4. It's positive 8 divided by negative 4. What is that? Negative 2, right? Yeah. And then y over y is 1. So it's x minus 2. Now we can check it by distributing. We better end up back up here. We do. Question. The negative in front, we know for a fact we've got to pull out a negative just because it's going to help us later on. Okay, let's do 1b real quick, a little bit harder of 1. So what's the greatest thing in common? First of all, I'm going to ask myself this, okay? So listen up. Does 21 divide by 14? No. Okay, but there still could be something in common. What do each of them, what's a factor? Factors being what? Multiply to be it. What do each of them have, what's the greatest thing in common? A 7. Do we have a negative in front? We'll plot a negative 7 for sure. Good. What else? X, right? Just x, because this one only has an x, so we can't pull out x squared. Y, oh, we could pull out y squared, right? Z and z squared, so we pull out a z. Now look, if I need to, and I still do this to this day because it takes me an extra 5 seconds, and I make sure I don't get it wrong. If I just rewrite it so I look at it. Oftentimes in secondary math 3, if you're lazy, you're not going to you're going to get things wrong more often, so it just kind of helps, even if it seems like I don't need to do that. Negative 14 divided by negative 7 is 2, yeah? X squared over x is x. Y squared over y squared is 1, z over z is 1. That's left in the first term. Now let's not put plus or minus in yet. 21 divided by negative 7.
3.
Positive or negative?
Negative.
Negative 3, x over x is 1, y squared over y squared is 1, z squared over z is z. We're golden. That, and then you can always check, because if you look back inside your parentheses, now it's much smaller, and you say, okay, yeah, there was nothing more in common, right? And it's okay, this is where you can easily fix it. Let's say it would have been 2x minus 4z. We would have needed to pull out another 2, right? So we just pull that 2 out and multiply it in front here. Does that make sense, everybody? Okay, sweet. Okay, this is for a very good point. Now remember, terms are separated by plus or minus signs. So look, this is a term, and this is a term. What's the greatest thing in common in each term? A 2? What else? Isn't x minus 3 connected? Yeah. So don't they both have an x minus 3? So we're going to pull out 2x minus 3. 2 times the x minus 3 is what I meant to say. So now we're going to say, well, what's left in our parentheses? Divide each by 2x minus 3, divide by 2, x minus 3. Let's see what's left in the first term. 4 over 2 is 2. X minus 3 over x minus 3 is 1. Negative 2 divided by negative 2 is negative 1. This over this is 1. So we have 2 minus 1. Well, now can't we combine that? We can. So we have 2 times x minus 3 times 1. So we have 2 times 1, right? We can reorder this in any order, right? 2 times 1 is 2. We have 2 times x minus 3. Now, this one actually makes sense because if you think about it, if we have 4x minus 2x, isn't that 2 x's? Everybody? So 4x minus 3's minus 2x minus 3's will be 2x minus 3's, just like up here. That kind of makes sense, everybody. So we just went about solving it, simplifying it a different way. Anyways, we simplified by factoring. Interesting. Okay. Sweet. So I'm not going to do this one. Can't you see what's in common? 2 and c minus c. That's what we factor out. Okay, go. Go for it. On the practice worksheet, that means your worksheet you picked up over there, you're going to do 1 through 4. Ready, set, go. Just kind of trust me with that. Like I said, my kids can factor. If I have my secondary 2 kids, holy cow, they come out factoring geniuses. Okay. So we're going to be factoring specifically a quadratic. So quadratics have the highest degree of 2. That's what makes it quadratic. So look up here, x squared plus 3x plus 1, that's what makes it quadratic is degree 2. Do you all understand what a quadratic is? X squared plus 2x is another quadratic. It's degree 2, that's quadratic. X squared minus 9, another example of a quadratic. X squared minus 3x plus 2, another example of a quadratic. So quadratics, you might want to take note of this somewhere. I don't know, it's up to you, you can just watch, but make sure you really pay attention. So quadratics have a standard form of ax squared plus bx plus c. So you're going to have to be able to identify a, b, and c to be able to factor correctly. So a is in front of x squared, b is in front of x, and c is our constant coefficient. A is in front of x squared, b is in front of x, c is our constant coefficient. And technically, we would always make sure before we factor that it's equal to 0. Standard form, guys, highest degree to lowest degree. Do you see how x squared has a higher degree than x to the first? And then this doesn't have an x. Technically, it has x to the 0, which is 1. So there's no x, so that's our constant coefficient. So 2x squared plus 3x minus 2, it's in standard form, we're golden. This is my a value, my b value, and my c value. You also include the sign. Does everybody understand a, b, and c? So negative x squared, technically our a value is negative 1, our b value is negative 3, and our c value is positive 5. Do we all understand what a, b, and c is? Okay, so now this is the method on how you factor. Take a picture of this so you don't have to take a note of it. I just take a picture of it. I'm cool with pictures if you can. So this is how I teach factoring, and it's because if I teach you how to factor like this, you can literally factor anything. There's no teaching tricks or anything. You don't have to learn tricks. You learn one method, you can factor anything that's factorable. So first of all, your first step is to put it in standard form. Ax squared plus bx plus c, and make sure it's set equal to 0. I should have said that. Sorry if I just ruined your picture. Your second step, this is important. You'll always hear me say, what multiplies, so follow me. We're going to be looking at what multiplies to be a times c. We're going to multiply a times c, and adds up to be b. This is our b value, right? So then we're going to list out factors that multiply to be a times c, and we're going to find the factors that could add up to be this b value. Now right now you're like, I have no idea what you said if you haven't heard it this way before, but you will understand what I'm saying when we practice it. So just trust me, don't say I'm already lost and zone out. It's not going to make sense till we do it. Our third step is, I call it drop and break. So we're going to drop down our end terms exactly how they are, drop, and then we're going to break. We break down our middle term, and we're going to rewrite that middle term as these two factors. Because you'll have these two things that add up to be b, and we're going to rewrite b as those two things. bx, I guess I should say. Our fourth step is to check your safe haven. You'll see what I mean in a second. I call it a safe haven. We get to a point where we can tell we've 100% done this correctly, and I'll show you why you know. That's always when I'm like, oh my heck, I did it right. Hallelujah. And then, so that's nice. You can always know you've factored right. And I'll tell you what I mean by safe haven in a minute. So once you've checked your safe haven and made sure it's correct, then you'll factor the safe haven out, and then you'll check it to make sure it's right. So it's going to end up looking something like this, for example. And that's two binomials being multiplied. Binomial means has two terms. Do you see how this has two terms? And this has two terms, and they're being multiplied. It's two binomials being multiplied. This is where you'll stop. You're done factoring. They're linear factors, meaning degree 1. So we'll factor it down to linear factors. Okay, questions? You probably have a million. You won't understand it until we practice it. All right, so 3A, here we go. Look at your page. Let's go through this. So the first thing to do is make sure it's in standard form. We're good there, right? Everybody? So then we say to ourselves, what's my A value? It's 1. We're going to go really slow at first. My B value is -7, and my C value is 6. I promise if we start out slow, in like another day, we're just going to fly through this stuff. Questions on A, B, and C. So now we'll ask ourselves, this is our second step. We say, we go over to the side, we set up our thing. What multiplies to be A times C and adds up to be B? So we'll multiply A times C. 1 times +6 is +6, correct? And then our B value is -7. Does everybody understand where I've got these things? If not, say, actually, let's say that one more time. Yes. So we're asking ourselves what multiplies to be A times C. So I did 1 times 6, which is 6, right? And adds up to be B, so I just put B right here. So we're just setting up this chart for ourselves. So now what we're going to do is we're going to list out factors of 6. Factors mean what multiply to be 6. Let's list them all out. 1 times 6 and 2 times 3, correct? Are those the factors that multiply to be 6? Okay, sweet. Now, if this is factorable, one of those could add up to be -7. Now, we're going to put our signs in now. So let's think about this. Couldn't 1 and 6 add up to be -7? But wouldn't both of them need to be negative? Well, let's see, does that work over here? Is -1 times -6 +6? Yes. So we're good, right? And then -1 plus -6 is -7. Do you see how I have check marks in both boxes? That's when we say yay. Those are our factors. Okay? So I'm just going to highlight those. Those are the factors we're going to be using for the break part. So now we're to the step drop and break. So I'm going to erase this so I have some straight down room. I like to leave under here blank for myself. So we're going to do this the long way. We're going to learn this the long way because there's certain quadratics you have to do it this way. Tomorrow I'll teach you one little thing, but if you know how to factor this way, you can factor anything. So now we're to drop and break. So we're going to drop down our n terms. So we drop, so n squared. We drop them down exactly as you see them. That's a +6. So we drop. Does everybody understand drop? Drop down your n terms. And now we're going to break. We're breaking down the middle term. So listen up. We're rewriting that middle term as these two factors. Now think about it. -7n. Can't we rewrite -7 as -1 and -6? Isn't that the same thing as -7? Now we're rewriting -7n. So these have n's. So we're going to insert those in for the break part. We're rewriting -7n as -1n and -6n. Now I'm going to tell you something. You can put it in any order on the break part. So I could have switched these and put first -6n - 1n. Now it would have been 5. Okay, so order doesn't matter, yes. Okay, if you remember, let me know. Yes, sir?
So like since there's not
Since what? Yes. No, A could be anything, that, and we'll get to examples like that in a minute. Yeah. Okay, does everybody understand drop and break? So now we're going to group. The next step is we have 1, 2, 3, 4 terms. We're going to group the first 2 terms. We're going to group the last 2 terms, including that sign right there. Does everybody hear me? Including that sign. Okay, and now we're going to factor out the greatest common factor. That's why we started out with that out of each group. So let's look just at this group for a second. Ignore this. What's the greatest thing in common in n squared minus 1n? n1, so 1n. So we're going to factor out an n, right? So we write our n. Now we've got to see what's left in this group, what's left in parentheses. So divide by n, divide by n. So that leaves me with in my first term an n, right? Minus 1. Is everybody comfortable with that? Now we're going to say, okay, are you sure? No questions? Now we're going to group this. We already grouped, sorry. Now we're going to factor out the greatest thing in common in 6n minus 6. Ignore this for a minute. Isn't there a 6 in common? There's a negative in front, so we factor out negative 6. So then let's divide each term by negative 6. So negative 6 divided by negative 6 is 1, and then there's an n left. Positive 6 divided by negative 6 is negative 1, right? Now look at that. Almost. This is where your safe haven is. Notice something. Isn't what's left in parentheses what left in parentheses the exact same? Sign and everything. If that's true, we say, phew, we've done this correctly. We factored correctly, because if you factored correctly, those will be the same. So now we can factor that out. We just did examples like this. In this term, isn't there an n minus 1 in common? So it's called, I say, you factor out your safe haven. So we're going to pull that out. Pull out n minus 1. So then we go back and see what's left. We'll divide each term by what we pulled out, right? Gone, gone. Left in the first term was an n, right? And then minus 6 left. Okay, now I want to point out something. Okay, well, I won't point out something yet. Are we all good? We factored it. Boom, boom, boom. These are 2 linear factors, the product of 2 linear factors. We don't need to write down multiplication signs. They're already multiplied right next to each other. We factored it. Yes. Yes. So notice, so he's noticing. So what are you noticing? So this is this, and this is this. So the reason I teach this is because that doesn't work if your A value is not 1. Does that make sense? Yes. Good point. But so that's why I teach this way. But yes. So I'll just get to it since you guys saw it, right? Our A value is 1, right? Everybody? So you notice that this was negative 1. We had a negative 1 and a negative 6. Do you see what it factored to be? N minus 1 times n minus 6. Much easier, right? Now the reason I teach you all that is because if this A value is not 1, and you do that, you get it wrong. It's not the right factors. That you have to go through this long method. Does that make sense, everybody? Okay, so let's do another one the quick way. So we're looking for what multiplies. So we have 3b, we have n squared minus n minus 56. So my A value is 1, my B value is negative 1, yeah? C is negative 56. So we always start out by saying what multiplies to be A times C and adds up to be B. What multiplies to be 1 times negative 56 and adds up to be negative 1. So 7 times 8 equals 56, right? But it needs to multiply to be negative 56. One of them needs to be negative. It needs to add up to be negative 1, right? So which one needs to be negative? Negative 8, right? Because 7 plus negative 8 is negative 1. it has to work in both boxes, and it does, right? Those are our factors. Is our A value 1? Yes, right? Positive 1, it has to be positive 1. It is. So we know that if we were to drop and break, in the end, we're going to have this factor to be, we're dealing with m's, m, and this is positive 7, right? Plus 7 times, and that's a negative 8. So we can kind of skip on this one, m minus 8, and that is the factored form. So yeah, you were able to see that cool trick, and that does work only if A is positive 1. Otherwise, you have to drop and break. Okay? So my question for you is, do you want me to let you just practice? I won't keep going through this. Are we understanding? We're all good? I'm not going to stand up here and keep practicing for you then. I just want you to look up here, though. Looking at x squared minus 6x, what's the quick way to factor this? Say, isn't there an x in common? That would be easy, right? We wouldn't go through a times c. Same here. Okay, just making sure. So these are all the easier ones. So do those. And then we'll re-go over one more time how to long factor. So practice that. Ready, set, go, check your answers with me. Calculators. So everybody knows 22. We have 2n squared minus 17n plus 30. Our first thing we do is make sure it's in standard form, check. Second thing we're going to do, we're going to look at all three terms and say, is there something we can factor out right now? Nope, right? 30 divides by 2, but 17 doesn't. So we've got to go ahead and do what multiplies to be a times c and adds up to be b. So let's quickly, I'm going to write over here. Okay, so my a value is 2, yeah? B is negative 17, and c is 30. I need some calculators. So we're going to go through the process. What multiplies to be a times c and adds up to be b, which is negative 17. Now guys, look, my a value is not a positive 1, so we're going to have to do this long factoring. But that's okay. We just need more practice with it. So let's list out factors of 60. 1 times 60, 2 times 30, 3 times what? 3 times 20. So go 60 divided by 4. What's 4? 4 times 15. Is there more? 60 divided by 5 is 12. 60 divided by 6, right? We have a lot of factors we can choose from. Yes. If you see it, then you can stop. Yeah, I'm just making a point here because guess what? There's times when one looks like it's gonna work and then it doesn't, and then you keep going and then you find them down here. Does that make sense? Well, yeah. So we've listed them out. Our factors. So it needs to have to be negative 17. Does 20 need to be negative or 3? 20. Now we gotta check, guys. If it doesn't work over here, this is a good one to do because look, is positive 3 times negative 20 positive 60? No. So those aren't our factors. Yeah, interesting, right? Yes. Good. So this was a good one to do. Because positive 3 times negative 20 is negative 60. Is our A value, or our A times C negative 60? No, if that one would have tricked us, we would have got it wrong. And they, on the ACT, will make sure to give you one. If they want you to factor, they'll do something like this, because guess what? 90% of students, 90% of people will put that. Does that make sense? Yeah, this is good practice for us. That's why I picked this problem. So we move on and say those must not be the factors. So let's find some others. So isn't 5 and 12? So if they were both negative, wouldn't that be negative 17? But positive 60, right? So negative 5 and plus negative 12, we checked it, and so good. We're golden. Those are our two factors. That's for the break part. So now we're going to drop. The drop part is you drop down the front term, you drop down the end term, signs and everything. We're dropping down 2n squared. We're dropping down positive 30. And then we're going to break. We're breaking down that middle term. We're rewriting negative 17n as those two factors. But remember, these are n's, right? So we're going to put, does negative 5 need to go first or negative 12? Doesn't matter. So I'm going to randomly choose to go negative 12n. It was actually strategically put. I chose that just because it's going to actually be a little bit easier if we do. Minus 5n. I mean, it will be the same process if we would have put that 5n first. But now look, We have 1, 2, 3, 4 terms. Anytime we have 4 terms, we group the first 2 terms. We group the second 2 terms, including the sign. And then we're going to factor out the greatest thing in common in each group. So there's another 2n in common here. Factor out a 2n. To see what's left, divide each term by what you're factoring out. 2 over 2 is 1, n squared over n is n. Negative 12 divided by 2 is negative 6, yeah? And n over n is 1. So we've taken care of that. Questions? And then we'll factor out the greatest thing in common here. Isn't it a 5?
Yeah.
Negative 5, right? If there's a negative in front. So we're factoring out negative 5. Divide each term by negative 5 very carefully. That's positive n. Positive 30 divided by negative 5. Isn't that minus negative 6? Our safe haven's the exact same sign and everything. Even if your sign's off, you've done something wrong. Our sign's the same, so we can factor out our safe haven. We factor out n minus 6, right? So then it divides out once we factor it out. So left is 2n minus 5. Now I'm going to have you look with me. That's the factored form, right? Aren't we done? Isn't that the product of 2 linear factors? We're done. That wasn't too bad, right? You'll get way quicker at that. Now look, if we would have went the quick route, like on quick factoring, would we have got the right answers? Yikes. You see how you would not have got the correct answers if we would have quick factored. So if your A value is not positive 1, you've got to go through the long process. It'll get easier. Any questions? Do you need another one off your worksheet as an example, or do you want me to let you just practice? Okay, number 24. So, what multiplies to be a times c, what multiplies to be negative 28, and adds up to be 3. So, won't that be 7 times 4? And it's negative 4, right? Everybody? 7 plus negative 4 equals positive 3. It works over here, it works over here. So now we're going to drop and break. So see how much quicker this one's going? Drop. 7n squared. We're going to drop negative 4. You see we drop? And we break. We're breaking down the middle term. Rewriting it as these two things, but with an n. So it'll be plus 7n minus 4n's. We have 1. I'm going to draw a line. We have 1, 2, 3, 4 terms. If you have 4 terms, you'll factor by grouping. In this group, the greatest thing in common is a 7n divided by 7n. Left is n plus 1. Yeah? See how much quicker the second one goes once you've seen that a few times. In common, there's a 4. In fact, we're factoring out a negative 4. Right? Divide by negative 4, divide by negative 4. Left in our parentheses is positive n now. N plus 1, check your safe haven. Yay, we factored this correctly. So we can pull out the safe haven. There it is. Now it divides out, leaving us with 7n minus 4. How many of you are like, I like this better than my teacher taught it this way, or my teacher already taught it this way? Sweet. Yeah. But it works every time. That's what's so nice is every time it works, so you don't have to learn tricks. You'll forget tricks. You'll run into something you haven't seen before. Anything that's factorable can be factored using this method. Yep. Okay, awesome. You guys are doing good. I think you're prepared. See, even this, we could factor doing that way. I'm not going to go through that one right now. Number 25, would we do a times c adds up to b? No. What's in common? This is on your worksheet. What's in common? P. So then left is 7p minus 10. We wouldn't make this a times c adds up to b. We could do that, but then it takes really deep. I mean, we could do that. Wasn't that 10 times easier? So we wouldn't do that because why make it harder? Okay, sweet. These are the problems that are going to be due. Anything else is just extra practice. You do not have to do it. However, if you did, it would help you.